Question 11b reads, you cut out the shape above and fold it along the dotted line AC so that the triangle ABC is on a vertical plane and the circular shape through the points AKC is on a horizontal plane. They want us to calculate the line straight from B to K once it has been folded. So in other words, they are telling us that this part the top has become perpendicular to that part at the top. So I'm not sure if I can draw it properly for you to be able to imagine it, but it's a little bit risen, and we understand that it will now be perpendicular to the plane, to the horizontal plane then. So that's our beam. The first thing we're going to do is calculate the length from B to, say we have a point, this point here. We need that height. In order for us to get that height, first let's get this angle. You can see there's that angle, depending on what makes sense to you. So we are going to use the cos rule that tells us that BC squared is equals to AB squared plus AC squared minus 2AC AB and cos of A. Okay, and to rewrite it, we'll get cos of A squared will be equals to BC squared minus AC squared minus AB squared over -2 multiplied by AB and AC. Let's plug those in. Square here, sorry. We have 29 minus 13 minus 64 over -2 multiplied by square root of 13 multiplied by 8, and we'll get that BAC is equals to 33.69 degrees. So that part is 33.69 degrees. We are looking for the length of, or the height of B from that point. We can see we can use the sine rule as its opposite of that angle. We'll say sine, not the sine rule, but the sine ratio of 33.69 should give us the height of B over the square root of 13, which is that side. And this will give us that the height of B is equals to 2 units. We will also look from A to this point, what is the length of that? So that would then give us cos of 33 will give us length of the line below B, so below B and A, this line over here, over again the square root of 13. And this will give us the length between the point and A at 3 units. Then the next thing we want to do is we want to calculate the straight line from K to the point below our B over here. So let me just draw in the line so we can see what we're working with. This is the line that we are interested in. We know that this will be 1 unit because AE was 4 units as a whole. And we know that this length is 4.88. So we are looking for the line that between that point and that point over there. So let's say that again. We know that from the point to E, our length will be 4 minus 3, which is 1 unit. So we can use Pythagoras theorem to calculate from the point to K, which will then give us 1. So that 1 squared, and our radius squared, giving us a final value of 4.98 units. Then we will draw a line. So we have a line that goes from B to K. Remember that this is perpendicular. That line there is perpendicular. So again, we can use let me get a different color and see if that will work first. We can use Pythagoras theorem to calculate BK, where BK is our hypotenuse. If we are looking at this triangle, just remember that it is perpendicular to the plane because one is vertical and the other one is horizontal. So we'll say from B to K would be, since it's our hypotenuse, would be the line of from B to this point over there, which is 2 units. And from that point over there, all up to K, we calculated this previously, which is 4.98 squared. Let me write my 4.98 correctly there so you can clearly see it. Okay. And we will calculate the length of BK as 5.37 units.